Hi, everyone, and welcome. We'll give everybody a few more minutes to join. I see more still rolling in here.
I'll just do a test. Rhiannon, can you hear me clearly? Okay, good.
Yep. You're good. Everybody is good.
I'll do my test as well. You can hear me?
Yes, you're also good and ready. All right, we'll give it one more minute. Looks like there's still a couple people joining. All right. Let's go ahead and get started. So I just want to welcome everybody to today's webinar featuring Global IDs and Fulcrum Digital. We will be covering interactive data lineage, the key to understanding your data. And I am joined today by Arka Mukherjee and Conleth Cunningham. Next slide, please. Today in this webinar, we'll be going over a brief introduction of the two gentlemen I am joined here by. Then we'll go into understanding data lineage, highlighting the importance of data lineage, and then covering data lineage through interactive visualization. And towards the end, we will have time to answer all of your questions. So throughout the presentation, feel free to drop them in the chat and we will get to those at the end of the presentation. So first, I'd like to take a moment to introduce our speakers. As I said, I'm joined by Dr. Arka Mukherjee and Conleth Cunningham. I'm going to turn it over to you, Conleth. Could you give us a brief introduction of yourself and Fulcrum Digital?
Hi, everybody. I realize also that there are going to be some people who will not be on live, so probably watching this in recording mode. But yeah, my name is Conleth Cunningham. I've been with Fulcrum for 2 years now. I joined during the COVID situation 2 years ago and adapting to the new set of clients and a company. But Fulcrum has made it incredibly easy and a pleasure to work with during that time. Initially, my role was to help with delivery with MasterCard, but more lately I've been moving into business development. But during this time, I have spent a lot of time developing partner channels alongside Rhiannon. And certainly working with Arka here, who's on the call, developing opportunities and developing how we can collaborate together and bring solutions to our clients. My background is IT, having graduated with a computer science degree a few years ago, probably a little bit more than a few years ago now. But during that time, there's been seismic changes in IT since I left uni, but I'm delighted to be at the leading edge of technology, working with Fulcrum and working with great partners like Global IDs. For the last 15 months, we've been developing this relationship together, and here we are presenting a webinar, and hopefully we can spend time with you going forward. Arka, do you want to introduce yourself?
Yeah, so I'm the founder and CEO of Global IDs. I left IBM to start the company in 2001. So happy to say that we've been able to carry on all this while. And we really enjoy data management, and it's a delight to have an audience that's also interested in data management. So I look forward to telling you more about it.
Next slide.
Okay, so no, there is a lot of detail on this slide, and if this was a normal presentation, it would be less busy, but we want to reduce the number of slides and get to the main show, which is talking about Global ID's product, deep. So I'm just going to cover some key points here. It is important to show that Fulcrum is a company that has a global footprint, is able to support your global business strategy, and be flexible and adaptable to your engagement model. We have 12 centers globally, and we work in a number of industries. The industry that I work in mostly is the financial services. And I think most of the attendees on this list are from the financial services domain, But we do work in insurance, higher education, e-commerce, food services, and a few others, as you can see at the bottom right-hand of the slide. Fulcrum is a company that, its ethos is really about partner-first relationships and engagement. We're a young company. I think Global IDs is also a young company, a little bit older than ourselves, perhaps, but our founder, Rajesh Sinha, and our CEO, Dana Kumaraswamy, they put a lot of emphasis on developing relationships with our clients. And all of our clients have been long-standing engagements with us that are growing year on year. What we bring to the table is a depth and breadth of expertise, talented and experienced professionals, and we invest in people. Rajesh and Dana have this as a core principle in the company, to invest in people. And this is more important than ever with the current challenges we have with the domestic market and the recruitment market on a global basis. I think we can move on from that slide to the next slide, which is not, can we just move over here? This slide is not any less busy. Again, perhaps if you want to go into the detail, you can replay the video or the recording of this at some point. This is meant to give you a flavor for the areas that we're involved in. We provide end-to-end services, and our core strengths are in cloud technology, payments, systems integration, platform development. We provide consultancy, we provide services with staff augmentation, or we put together teams, obviously onshore, nearshore, or offshore. We help build business platforms. So we're quite flexible, and what's depicted here is really a little bit of a history of our experience to date. This is not what we're talking about in the future. This is what we do today and have done in the past. So this is our experience and this is our depth to date. It's continually expanding and growing. And the key message here, again, is in the financial services area, but we do have many other strands of Fulcrum Digital, including website development and e-commerce sites and what have you. So this is meant to convey the breadth and depth of the services that we can bring to our clients. Next slide, please. So our partnership is based on the core product that Global IDs and Arka's team have developed. The platform is called DEEP, or that's the acronym for Data Ecosystem Evolution Platform. Today's topic is primarily focusing on data lineage, but there are other aspects that are available on offer from this platform, and I think Arka may cover that in a little bit more detail. Today, we're talking about data lineage, but data quality, data privacy are also other key aspects that the platform can offer. The platform also can be deployed on-premise, but increasingly, it's the preferred choice is to have a private cloud-based platform deployment. I think it's well documented the advantages of going cloud, and so I don't need to go into that in this pitch. Machine learning is also a key component in the delivery of this platform and the delivery of the components. So again, Arka will be able to showcase that during the demonstration and coming forward. I think we can go on to the next slide, please. Back one, I think. Can we go back one slide?
There you go.
Oh, okay. I was going to cover the partnership delivery side of it. I think we're missing a slide, but that's okay. We maximize the strength that both parties can bring to the specific needs of our client. Of course, Global IDs can do the full deployment themselves, the full project implementation. They have the history, they've got the depth of clients and experience. But the partnership that we're working on together will allow Global IDs to provide and focus on the SME, subject matter expertise and consultancy, but also to work on the product development and roadmap. They have the history, the experience, the depth of years working in this area. Their focus is really about data, whereas Fulcrum has a wider brief and a wider portfolio of solutions as such. What Fulcrum can bring to this partnership, and does bring to this partnership, is a complementary global footprint for project delivery and client engagement. We will get involved in the delivery aspects, the technical skill sets for installation, integration, training, ongoing customer support. Fulcrum will evolve as our practice evolves. We will have a Fulcrum data management practice. And as that expands, then we will also be able to provide more consultancy and support Arka and his team in rolling out this product and expanding our client base and going forward. I think that covers the partnership. If there's no questions, I think we're going to leave questions to the end. Oh, there's the partnership slide there now. Okay.
Yep.
I think that covers the bit I'm going to cover, and I think I'll hand over to Arka, who will cover the problem statement and then take us through the aspects of the deep product itself. Thank you.
Lovely. Lovely. All right. So let's start talking about data lineage, what it is, and how it's relevant. So I presume that many of the people who are attending the webinar are here in order to, because there's either they have a background in data lineage or would like to understand how the, what the problem is and how it needs to be solved. So I'll start with a preamble in terms of saying, all of us have been working in data management for the last 20, 30, 50 years, right? This field has matured a lot. And so what is it that's new and what is it that is exciting about the field as it stands today? And so we'll start with this idea that data management for the last 50 years has been by and large an observation of static data environments, that you're looking at databases at a point in time and everything is at a point in time. What's different about what you're going to see today is that we have a different vision of what data management is going to be in the near future. And that is the vision of a dynamic data environment where all data is always changing, it's always moving, and that idea that we need 2D environments are inadequate in order to sort of go into understanding the complexity and the dynamics of data. And so what we are presenting over here is a very new theme that you will not find anywhere in the industry, where we are saying here's an important problem in all industries, but specifically, particularly in financial services, and that in order to deal with the problem with all the relevant complexity, we need to sort of move into the 3D metaverse. Okay? So that's what we're going to show today, and so let me get going in terms of explaining the problem to you, and towards the end we will actually show you all of this working in 3D. Okay? So who's so if we look at the problem of data lineage, it's simply defined as the flow of information across the data ecosystem, which means that you have a particular table in a particular database. It might be the origination system on the left-hand side, and then in the middle you have some intermediate systems where that same data flows into, and then you have some destination system, table 3, where the data lands up in. This is happening for all our data in all our systems, right? So if we had just one database to run our companies, we would need data lineage. But in most financial services environments, you have thousands of applications, hundreds of thousands of databases. So understanding all of this is somewhat complex, right? But at a high level, all we're looking at is the movement of data from one table to another table across the systems and the data ecosystem. So moving on, what we why all of this is important is that so there's a number of regulatory demands that are being placed on the industry, and that when we each industry, and specifically the financial services industry, has a large number of regulations that it needs to meet, and so that is a requirement for understanding lineage and explaining to regulators. I'll go into this in a little bit more detail. Second is forensics. If something goes wrong, you need to find out where the problem originated. And so if you're looking at downstream systems, you need to go to the upstream systems where data originated. And impact analysis is if you change an upstream system, what are all the downstream systems that are going to be impacted? So for these three reasons, and there are a number of other ones as well. For these three reasons, data lineage has become suddenly prominent and is becoming a second order problem on top of all the data management that is being done. So moving on, when we look at the financial services in particular, we've been working with many of the large financial services companies over the last decade, and essentially we look at these reports that are demanded from each bank in terms of showing that they have transparency and traceability into their data environment. So the liquidity reports are very fundamental to make sure that the bank is solvent, and of course, like the 2052A Federal Reserve report is a very critical aspect of that. The question, of course, that the regulators are asking is, if a bank is presenting this report to the regulator, how can they trust it, right? How do we know that this data actually originated from the systems and not from somebody's made-up spreadsheet, right? So, the trust that one can place on the report is only based, should be only based on show me all the systems where the data originated from, and show me how it flows into these target reports. So this is creating a fair amount of demand for data lineage in the financial services, but in every regulated industry, there's an equivalence, of course, and also in the problem of privacy, when one has to look at information about individuals as it's flowing through systems, it's a fairly universal requirement. So moving on, we've been working on this for about 6-7 years, and it's considered a pretty hard problem. And the reason why it's hard is because ecosystems are operating at a large scale. So many of the banks we operate with have thousands of applications and hundreds of thousands of databases. So data from any database could be moving to any other database, and so you're dealing with an n-square problem where n is 100,000 databases. So it's just massively large, massively complex, and therefore it is hard to solve without significant armies of people going in. And of course, the further thing is that the data are disorganized in most of these environments, so nobody knows sort of where to find the right data and see how it's. So these three problems are the main barriers that have presented data lineage as being a particularly hard problem. And there are a number of vendors who are attempting to solve the problem, and we've been at it for more than 5-6 years. So moving on, why, in addition to the regulatory problem, there's of course the problem of simplification. Why do we need all this data? Can we find out how to simplify the whole environment? So let's. There are 4 steps in order to think about how we simplify the environment. So the first is we need to understand and discover what data that we have, and we need to have a full inventory of all our data assets. Right? It's sort of ground truth. And then moving on, we say we need to understand what all these tables and columns they mean. So we have to go through a classification and a mapping exercise. So once again, this is foundational, and then it's only at that point that you can get into the problem of lineage and understand how information is flowing through. So I'm getting into the how, and I'll go a little bit more into the detail. So let's go into each of these steps and explain a little bit of the detail of what is required before we actually can get to data lineage. So the first area of data discovery is oriented around finding what data assets one has, and then so the way our software essentially solves this problem is that it connects to various databases, and it queries the database to say what is the metadata that you have, meaning what are the tables, what are the columns, what are the indexes, what are the primary keys, etc. And so we pull all that information and stick it into a metadata repository that essentially compiles this inventory in an automated way. To get further insight into the data that exists, we do a statistical analysis of all the data. And so by statistical analysis, I'm talking about understanding means, understanding depending on the data type. We look at distributions, we look at patterns, we look at allowed values, we look at outliers. So just we apply as much statistics as possible on the data to get an understanding of what does this data really mean. There's a column called cost inf or something like that that's humans can't understand. But if you look at the data, here's the statistics that comes out of it, and so maybe it looks like a customer ID identifier, for example. And so that's the profiling problem. But what we have discovered that the most important thing is this idea of sort of constructing a fingerprint. So Global IDs sort of essentially creates a fingerprint for each of the columns that it goes through, and we do this automatically for millions of fingerprint, millions of columns, and we are able to sort of create a unique fingerprint for all of it. So this is sort of foundational step. It's all automated. It's all that needs to be done is connection into the various database environments, one-time read-only connection, and you collect the fingerprints. The next step behind that is the problem of classification, where we say that where are all the columns of the same type? And here we've already done the preliminary work of getting the fingerprint, and so we use a machine learning program in order to say, here's an example of a customer identifier. Find all other customer identifiers in the landscape. Here's a responsible. Here's a column for customer accounts, and so find all account information in the landscape. So this supervised learning makes it easier to take each column and put it inside a particular bucket. And because all these buckets are based on common fingerprints, we are able to organize all the columns in the landscape quite easily. So just moving on to the other steps, we classify all the identifiers that exist inside the landscape, and then we have neatly put each column that we have encountered and put it into its own sort of conceptual bucket, and we can search and find anything that is of interest. So with this step done, all the columns are organized. Now we need to organize all the tables, and for the tables we run through a similar process where we say, is this an example of a customer table? The software is taking a guess and saying this is an example of a customer table. Tell me whether it's yes or no, and then I will find all other customer related tables inside the data environment. So I go through that exercise for any object of interest and map my tables together. So these two foundational tasks, the column classification and the table mapping, is sort of an essential step to understanding how information is flowing. The additional step that one can also add in that process is to understand where master or authoritative information resides inside the environment. So with that, if you do these steps, we are actually in a good position to now address the problem of lineage. Not just lineage, a whole bunch of other things, but we are talking about Lineage today and saying this foundation puts us in a good position to understand Lineage. So the steps that are done subsequent to that is, one can take a human approach towards saying, okay, these are the tables that contain customer data, and I know where the master table or the origination table is, and I can then manually say that these are all the tables that are connected. That is the simplest thing, and many of the software companies are sort of focusing on the human attestation method. Global IDs is more interested in evidence and proofs, scientific proofs. So we are looking at overlaps of data as data moves from one environment to another. We're also looking at overlap or common data or common records as they are flowing through these environments as further evidence. But our feeling is that once we have proofs, then that should be adequate for the regulators to say, okay, there's a complete transparency and complete traceability in the data ecosystem, and that should be adequate in order to satisfy the regulatory concern. So I've explained at a high level and at a medium level the various steps involved in order to solve the problem. Now moving on. This is a quick demonstration of what is the outcome, right? So the outcome is I want to look for a customer ID, a specific customer ID that's put in that search box, and I want to see how it's moving from table 1 to table 2, right? And so essentially we can look at that one ID value moving from various tables, and these are the tables, and these are the tables in the various applications that are moving. One can also go into a linear view of here are all the tables, and we can drill down into the arrows and see the state of the data element as it's moving into those environments. So moving on. So this is sort of an example of an outcome. So let's now say that, okay, if you have lots and lots of data, how does this? How can you do this at scale? How I have many thousands of tables containing my customer data. Where is it? How do I see it? So in order to do this at scale, one has to now say my 2D environment is not adequate. I need to represent lots of information. So if a picture is worth 1,000 words, maybe a 3D environment is worth 1,000 pictures in showing what these environments actually look like in the complexity in a holistic kind of way. So part of what Global IDs is trying to do is to show these holistic data movement across the environment. And so this is a sample, but we'll go into the actual application at the end of this presentation. So now moving on. So let's actually go there. So here's the sample use case. So if we look at regulatory compliance for one of the reports that I talked about earlier, so there's the report that is highlighted at the end, and we say that these are the 3 tables that brought data into this regulatory report. Right? So here are all the originating tables, here are the intermediate tables, and this is how data. And here's the proof that we didn't make this up, but there's actually data overlaps. You can see the Venn diagrams in the middle. The Venn diagram says that for each source and target table, we have proofs of the actual values of the data flowing from the source to the target. So so it is not just a guess at what is happening. It's actually accompanied by proofs to say there's between the source, any source table and any target table, any pair of tables, here's the Venn diagram of the values that are common to them. So if data is moving, there has to be commonality. If no data is moving, then obviously there will not be commonality. So this kind of proof is provided along with everything else. Now, if we moving on to the next slide, then one can go into all the different kinds of lineage that exist, and so one can now put a governance framework to make sure that everything stays in their expected lanes, and they're not crossing over lanes and creating data quality errors. So we provided a number of sort of dashboards that look like this that would allow us to monitor the data as it's flowing from environment to environment, making sure that there are no lack of conformance problems or outlier problems or data quality or data policy violation problems. So operational monitoring of the data as it's flowing through. And then lastly, the impact analysis use case that I talked about earlier, if you have this kind of flow and you're redesigning your downstream systems, you need to understand sort of what is it that has come from the upstream systems, and that if you redesign your downstream systems, what is going to be impacted, right? So this gives you a sense that once you have this this lineage diagram, designing new systems or modernizing your environment, this is sort of an essential requirement before you modernize any of your downstream systems. So I'll end the slide part of this presentation by just moving on to a couple of steps which I've already described. So go ahead. Yeah. So step one, as we have talked about, is here's how you discover the data, what I described earlier, and say, so the software has at that point discovered a number of business entities, various applications, various databases, various schemas, tables, columns, etc. And one can then have the ability to search for all of that. Next. So here's a screen that describes sort of how we go ahead and classify the data. So each column, looks at its fingerprints, and based on the fingerprints, we are able to put each column in its right bucket. And so, this is the machine learning part of how you classify a column and put it all in its appropriate bucket. So just what the user is doing is clicking those yes, no columns on the side, and the software is learning, just like you teach a baby about what what something is. So the software is being taught, and a model is being created for a business concept. And as a result, once a model is created, every new database that is scanned is you already know what's in that database, regardless of how it is named, right? So what this part really solves is the problem of the fact that names are not used consistently across databases. If everything was named accurately, then you wouldn't need a lot of this. But most large organizations, they don't have naming conventions that are followed, and as a result, anything could be named anything. And so this exercise is required. Next, in the third step, as we had mentioned before, how do you map all the tables of interest? So if I want to do lineage on my customer data, I need to know where all my customer tables are. If I need to do lineage on my my loans data, then I need to know where all my loans tables are. So this third step is finding all the loans that are relevant to the lineage area. And so we are able to sort of locate all the tables that are of interest and temporally organize it in a temporal scale. So so once again, because these screens are a little bit small, and because the problem is very complex, it's a little bit difficult to sort of explain it inside 2D environments. So we're going to move into 3D environments to show you how this is done. But this is the requisite step as well. And now moving on to the next step. So the software at that point essentially has found the tables that are of interest, and then it creates hypotheses about the potential flow of information across the environment. So it's it's complicated looking diagrams that look like this, but the user is able to say, yeah, I agree with this, I disagree with this, etc., and then ask the software for proof, right? So those 4 steps essentially give you lineage with proof, and which is sort of the end user outcome that you want. Now, okay, so that's pretty much all that I wanted to talk about, and we will show you sort of the outcome in 3 dimensions. So let's move on. Can we move on, please? So we'll just go through the part which I said is new into the environment, and all of you know that there's a lot of work that's happening in the metaverse, right? Where the work that we currently do in 2 dimensions is now going to move into the 3D environment, and the 3D gives us the ability to represent the complexity of the entire environment. And so I'm going to ask my colleague Shutapa to go into the 3D environment and show a screen, and we'll move through stepwise how that is done. Okay, can you display?
Yep.
Yeah.
She's just getting it all set up, so it'll just be 1 second here, and then should be
Okay.
right now.
Okay. All right. Yeah. So I don't know if anyone in the audience is familiar with what is happening in the metaverse. Right now, it's fairly preliminary, and so if you've seen the movie Ready Player One, where our current reality is sort of moved into 3D spaces, that's the programming paradigm. Okay? So what we have done here is to essentially go through the data lineage problem and say, how would you solve it in 3D, right? And so in our first step, which I've already sort of covered, we can first say that here's the complex data landscape that your organization has, and we talked about the idea that we would scan all the systems automatically and create this inventory of all the applications that exist inside the environment, showing the true complexity of the environment. Part of the problem with data management is that it is hard to boil down the work that we do into parts that actually tell a story. So what we are doing is data storytelling with respect to and showing management that here's the true complexity of our environment. Here's all the data that we have on a global basis, right? So that's the first first step, and then you can sort of drill down and go into each application, and you can go down into each application, and you can say, here's how data from one application is flowing into another. Once again, there are lots of nodes and lots of vectors across the nodes. So very hard to do all this manually, even harder to understand. So having this 3D environment where we are showing how specific kinds of data are moving from environment to environment becomes important. So the question, of course, that we're asking is, through data lineage, how do we solve the problem of data flowing across the application landscape, right? So that's sort of the second step of the story, that here's the data we have, and here's potentially the flow. Now, how do we get to this flow, right? How do we get to this? So as we have discussed previously, we said that first we need to understand sort of what data exists inside the landscape. So in this particular visualization, Global IDs is able to sort of look at applications, look at databases, look at schemas, look at tables, look at columns, right? And construct the hierarchy. And in many of our financial services customers, we are looking at millions of columns, hundreds of millions of columns, in fact, right? And saying that this is the hierarchy of data. That here are the applications we have, here are the databases we have, here are the schemas, here are the tables, here are the columns. And so this is a very large hierarchy representing complexity at a millions of columns, hundreds of millions of columns. We think that in some of our large financial services customers, 1 billion columns of information in their environment. So, but it's all categorized and organized over here in this physical hierarchy. So moving to the next part, we then say, so I have all these columns of information, but how is it organized according to the way I do my business? I do my business in a particular way, and how all the columns in my database is related to the way I do my business. So that organization is critical to answering any business question. And so the software then goes into that organization part, which I described as classification and mapping, where we say, what are all the business concepts that you run your business on? And then, so moving on to the next step, we are able to say that, okay, here are the things that we run our business on. So, trades and I'm not able to products and clients and persons and patients, whatever, right? So there's a whole bunch of things that are business concepts that the business runs on. So here's the semantic model of how the business is running. And so we understand how the business is running. And now we need to relate the way our business objects are related to our data objects. And so we are able to sort of link all this together and say, this is how a particular part of the business, a particular business problem is being understood in terms of the actual data that sits in the databases. So moving on to the next part of the flow, this ability to connect the way we do business to the way our data is organized is critical to solving a large number of data problems, but Lineage being one of them, right? That we say that, okay, if I want to understand the flow of my customer data, I need to understand how my customer IDs are flowing, where my customer IDs are, which are the tables that contain my customer IDs. So this linkage of business objects with data objects, which most organizations like really struggle hard with, right, becomes sort of a critical barrier that has to be solved in order to solve the lineage problem. But once we do this, now we can find all the business concepts of interest. You can do a search, a Google search of your environment and say, where are the objects related to this particular problem that I'm interested in, right? And so the search can now yield a data lineage diagram that looks like this. And essentially, what we're when it says that here are the tables that contain the objects of interest, and after we look at the timestamps associated with each of the tables, this is how they are organized in the time dimension. So there's table 1, the originating table on the left hand side, and then the destination tables on the right hand side, and this is the sequence at which we are flowing. So if you ask for proof behind that, you can say, okay, here's the code that takes the data from one place to another place. And so if you look at the code, here's the code, the ETL code that made table 1 go to table 2. Here's the ETL code that made table 2 go to table 3, etc. So there's no ambiguity anymore, right? And that essentially every step of that lineage diagram is now displayed over here. So so now so further evidence of proof can come from the overlap of data. So so our software is able to sort of generate all the elements, the data elements in each source and target table, where we can see that there's a Venn diagram of overlap between the data values as they are moving in. So So not only is it a diagram that sort of visually shows how data is moving, but also there's proof, there's evidence and proof to make sure that that's not a made up kind of story. So moving on, so what you end up with is something like this that says that here's how the data is moving across the environment, and that we have proof and we have evidence and proof to say that this is real, and that this is proof that we understand, we have transparency into our environment, and that we have the ability to trace each piece of information as it moves through our environment. So that's sort of the outcome that we want to go to, and then it creates a whole bunch of benefits beyond that. But at the end of it is like now, for many organizations, it's the first time they're seeing the environment in a dynamic way, right? For decades now, we've been used to looking at data in a static way, but with the access of these 3D metaverses, we're now able to represent the information in a dynamic way, where dynamic, holistic, and interactive way, which takes it a step beyond sort of what most organizations are currently doing. So that's essentially, yeah, we're at the end of the presentation. So Rhiannon, let me turn it back to you. And if there are questions from the audience, then we can address it. Okay. So let me turn it back to you.
Yes, and thank you for going on through all of that. That looks awesome. So just a couple of questions. We'll start with this one. How long does a typical implementation generally take before you start to realize and be able to see these benefits?
Well, it depends, of course, on how you define the scope. If you want to define your scope at a line of business level, and let's say you have 100 databases, yeah, that would take something in the order of like 6 to 8 weeks, I would say. There are some assumptions built into that. But at the end of that, because most of the steps we are trying to automate, and so the human involvement is somewhat limited. And so maybe 6 to 8 weeks, yeah. On a stretch, it might be 12 weeks, but that's the LOB kind of implementation. Many of the global IDs implementations that we do are global implementations, across data that's moving across multiple countries around the globe. So those things could take longer, and in many cases it does. In some of our larger banking clients, it takes years to do this, but those are truly enterprise level use cases. In most situations where you're trying to deliver value, our preference is that unless you do it within 1 quarter and you demonstrate value inside 1 quarter, it's hard, justifying the expense is sometimes difficult. So yeah.
I think also there's a phased approach is also an option. You can actually do it in bite-sized chunks as such, and you can get results out within 4 to 5 weeks as such. But as Arka says, it depends on the complexity and the scale and the scope that you're trying to address. But perhaps doing it in a phased manner can actually deliver results speedy, early, and use that as a learning and a platform to actually take on board your full data footprint going forward.
I would say, Conleth, one more thing is, of course, the familiarity of our platforms. Can we just not have the presentation on, please? It's distracting. So, can you just turn off the presentation? Yes, thank you. So, Conleth, I guess the point is, if like, let's say Fulcrum is already working on the environment and is already familiar with the environment, then we can accelerate it even more, right? Because yeah, so there the dependencies are, what is the level of familiarity in terms of the person who's doing the implementation, right? Is access to databases available, right? And can the feedback for the supervised learning be provided quickly? Those are really the dependencies. The rest of it is run in through automation with massive amounts of parallel processing. So a lot of this can be accelerated.
Yeah, but also to help, sorry, just to finish, but to help actually get through this as quickly as possible to deliver the value, Global ID does have a large library of adapters and connectors to numerous databases and file types that are out of the box as such. The list is quite impressive. I mean, I think Rihanna was trying to showcase the list visually on the slide deck, but we can certainly share that with the attendees at a later time. But we have an extensive list of adapters and connectivity to nearly every commonly used database or file type out there. So that helps speed up the whole process as well. Back to you, Rihanna.
Yeah, okay, we got another question here. Most data cannot be linked as data linkages tend to be removed or lost in data usage. So what role do human actions and assumptions play in recovering these? And then what level of accuracy of lineage do they achieve?
Yeah, that question is really the heart of the problem. Right? So linkage across these database environments is difficult. Linkage from a business perspective to a systems perspective is hard. So the whole problem of linkage is really at the heart of solving this problem. So as the questioner has said, if the linkage is removed, how do you tie it in? So the process that we have described is a very systematic way of deriving the linkages across the physical environment and across business and physical environments. So this approach that we have talked about in our experience is a very systematic way of solving the linkage problem and thereby solving a variety of problems, which lineage is only one part. But if you think about it, data quality is very related to that problem of linkage. Or if you look at analytics and predictions, that is also directly related to the problem of linkage. So linkage is the heart of it, and the way to solve linkage is through mapping and classification with as much automation as possible.
Another question here is, can you use the discovery results for identifying or locating personal information? And would you consider that a stated value proposition of this product?
Oh yeah, that's a huge value proposition. It's just one of the natural outcomes just comes out of this effort, right? So we are able to classify all the PII data that exists inside this data environment. And as a result, because we can identify it, we can, of course, from a security perspective and data protection perspective, make sure that all that sensitive data is subject to encryption policies or masking policies. But furthermore, I think with all the new privacy regulations that are all popping up all over the world, we can be in compliance with those privacy-related regulations as well. So we can provide proof and evidence, right? Evidence and proof, sorry, in terms of those, let's say, GDPR or CCPA or any of the state regulations, that we can prove that we are in compliance with those regulations.
Okay, great. That wraps it up for the current questions that we have. So I just want to say thank you to everyone who joined us today and took time out of their busy schedules. We will be following up with a recording of this presentation. Do you want to say anything else, Conleth?
No, I thought you were going to present the upcoming webinars, perhaps, that might catch somebody's interest, if possible.
Yes, we will have a list of additional webinars coming up.
Let's bring up that slide, right? So so to those of you who are interested in data management and seeing sort of what the advanced edge of data management is, this is sort of one of a series of webinars. Can we bring up that slide if possible, right? And I'll just highlight. some of the things that you will learn in our upcoming series of webinars. So right on top are the various business data problems that are emerging in this space, right? So how does one use data in order to create a dominant position in your market niche, right? The second one, data simplification, is I have this very complex environment. What are systematic ways via which I can simplify the environment and reduce cost, right? Data observability is a new problem that many of our customers are seeing, that I need to observe the data over time, and I need to create this, what I call as dynamic data. So the problem of data observability and dynamic data are somewhat related, but those are fairly universal business data problems that everyone's sort of thinking about. In the governance area, we have a large number of use cases. We've covered some of them today. Today we talked about data lineage, but problems of quality and privacy have come up, along with problems of redundancy, retention, change monitoring, and pipelines. So these are various future seminar topics. The part that I myself am very excited about is the innovation that our organization is doing in advanced data management or futuristic kind of data management. So which is more on the cutting edge and sometimes on the bleeding edge. But the use of mathematical graphs is becoming more common. Knowledge graphs is sort of what that area is. So we have projects that are related to knowledge graphs. We've shown you some of the things that are related to metaverse and 3D representations in augmented reality. Newer areas where we are going to do webinars is quantum computing, blockchains, data mesh, and scalable AI, all of which are just entering the market right now, but may not be mature, in the next 1 or 2 years. But nevertheless, we are investing a fair amount of time in creating products in those areas on top of our platform. So, if anybody is interested in those topics, please let Fulcrum know, and we'll be happy to do one-on-one webinars for you as well. So, thank you. Yeah, go ahead, Triana.
Absolutely. Yes, thank you. Thank you for reminding me to show that. And thank you again to everybody for joining us. If you have any additional questions, feel free to reach out. And like I said, we'll also be following up with a recording of this presentation.
Lovely. Thank you.
Thank you, everybody.
Thank you.
Bye.